variety of statements. Variety of statements. Variety of statements. Variety of statements. And are, but, then, which are not always precise and unambiguous. So, however, the connectivities that we introduce and use in logic are analogous to these connectivities, but are defined precisely. After introducing and defining five connectivities. Five connectivities. What are the means connectivities? First one, negation. Second one is disjunction. Third one is conjunction. Fourth one, conditional. Fifth one is biconditional. The also known as the implies and implied implication. So we find that the set of all such statements with the connectivities is well defined. So constitute an algebra. This algebra finds interesting applications in the design of computers and in the field of switching theory. So first one is negation. 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 We defined by this negation. We defined by truth table. How do we'll construct the truth table? P. Negation is denoted by like that symbol. Negation P. Suppose P is true. Negation P is false. Suppose P is false. Negation P is true. Okay. Next. Definition. Next definition is disjunction. Definition conjunction. So let P and next definition is conjunction. Let P and Q be two proportions. The proportion P and Q denoted by P and symbol Q is called the of conjunction of P and Q. The truth table for P and Q shown below. Okay. So next second one is conjunction. Conjunction. It is denoted by suppose and symbol. P and read as P and Q. P conjunction P denoted by P and Q. This is also will define by truth table. P. This is Q. P and Q. P. Q. P and Q. P and Q. So P is true. Q is also true. Then P and Q is true. Suppose P is true. Q is false. False. P and Q is also false. Suppose P is false. P is false. Q is true. P and Q is false. Suppose P is false. Q is false. P and Q is also false. Is also false. Next, third one, disjunction. One is disjunction. Definition. Definitions. Disjunction. 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 Let P and Q be proportions. The proportion P R Q denoted by P R P R Q. Read as R. That is and. Okay. PRQ denoted by PRQ is the proportion that is false. When P and Q are both false are true otherwise. So the proportion PRQ is called the disjunction of P and Q. Okay. So this is also well defined by truth table. This is P. This is Q. PR disjunction. PRQ. PRQ. So here P is true, suppose Q is true. PRQ is also true. Suppose P is true, Q is false. PRQ is true. Next, P is false, Q is true. PRQ is true. Suppose P is false, Q is false. PRQ is also false. Right. So example, I shall attend the class or go to the library. First, the daily life. 50 or 60 people died in train accident. Students who have taken mathematics, the students who have taken mathematics or physics can opt this course. Okay, example. Next definition. Hmm? Next definition is exclusive or P and Q. Exclusive P and Q. Exclusive P and Q. Mhm. P and Q. Exclusive P and let P and Q are proportions. The exclusive are P and Q denoted by exclusive. Exclusive denoted by circle plus. Circle plus. Circle plus is the proportion that is true when exactly one of P and Q is true and is false. Otherwise, will define exclusive. Exclusive are the true proportions defined by truth table. P Q P circle plus circle. Q. This is known as exclusive. Exclusive or P and Q. So here P is true. Suppose Q is true. P circle plus is false. Suppose P is true. Q is false. So P circle plus is true. Suppose P is false. Q is true. P circle plus in circle. Plus in circle is true. Suppose P is false. Q is false. P circle plus is false. Okay. Next, conditional statement. conditional statement. Definition. The definition is conditional. That is definition. Conditional statement. Conditional statement. Conditional statement. Conditional statement. Conditional statement is denoted by P implies, also known as implication also. P implies P implies Q. Or Q authors will write arrow. This is also P implies Q. Or also known as implication. So if P and Q are statements, the compound statement P then Q denoted by P implies Q. P then Q. P then Q. P then Q. So called conditional statement or implication. Implication or implication. The statement P is called the antecedent or hypothesis. Antecedent or hypothesis. And Q is called the consequent or conclusion. P is called antecedent or hypothesis, and the statement Q is called consequent or conclusion. Consequent or conclusion. Consequent or conclusion. Consequent or conclusion. So this is also defined by truth table. Defined by truth table. P implies Q is a false. Where P is true, Q is hello. Okay, so defined by truth table. P, this is Q. P implies Q. Q. P implies Q. P. Suppose P is true. Q is also true. P implies Q is true. Suppose P is true. Q is false. Q is false. P implies Q. False. Next, P is false. False. Q is true. Q is true. P implies Q is true. Next, P is false. Q is false. P implies Q is false. So because implication allows the many places in mathematical reasoning, a wide variety of terminology is used to express P implies Q. Okay, if P, then Q. P implies Q. P only if. Okay, next. So example, form a implication P implies Q. So P is, it is raining today. Q is, all rational numbers are real. So P implies Q means it is raining today. Then all rational numbers are real. Second one, example. So P, it is snowing. Q, 3 plus 5 is 8. So P implies Q. If it is snowing, then 3 plus 5 is 8. So next, next one, find converse and uh, contrapositive of implication. If today is Wednesday, then I have a physics lab. Solution. So if you have a physics lab today, then today is Wednesday. So contra positive of the implication is if I do not have physics lab today, then today is not Wednesday. Okay, next. Next definition. Biconditional. 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 And it is denoted by P implies and implied. Implies and implied. Implies and implied. Implies and hmm? So let P and Q be proportions. The biconditional P implies and implied is the proportion uh, that is true when P and Q have the same truth values and is false otherwise. Sometimes you use P implies and implied Q instead of P implies and implied. So this is also will defined by truth table. P, Q. P implies unimplied or biconditional. Because P is true. Q is true. P implies Q is true. Suppose P is false. Q is true. Huh? Then P implies and implied is a false. Suppose P is true. P is true. Q is false. P implies and implied is false. Next, P is false. Q is false. So P implies and implied is false. True. Right? Next. So note that the biconditional is true precisely when both the implication P implies Q, Q implies P are true. Right? Because the terminology P, if and only if Q, if and only if Q, we used this biconditional. Otherwise, the common ways of expressing the proposition P implies and implied. So P is necessary and sufficient for Q. And if P, then Q, and conversely. Next, example. For suppose the example, you can a berth in compartment Q, you have a reservation ticket. So P implies and implied. You can occupy berth in compartment if and only if you have reservation ticket. Observe, P implies and implies is true if P and Q are either both true or both false. So if you have reservation ticket and you can alpha both, so you can you do not have reservation ticket and you cannot occupy berth in the compartment. Okay. So one more example. Let P and Q proportions. P, it is below freezing. Below freezing. Q, I is snowing. Then, so it is below freezing and snowing can be written as P and Q. It is either snowing or below freezing can be written as P or Q. Okay. Next, truth tables, well-formed formulas. So, we'll discuss one truth table. So, in order to construct the truth table, the statement formula, formula P and Q. Statement formula P and Q. Statement. Statement formula. Statement formula. P and Q. P and Q are negation P. Negation P. Okay, we'll construct a table. Truth table. P. This is Q. P and Q. Negation P. P and Q. P and Q. Negation P. P and Q are P and Q are negation P. Okay. So P, suppose P is true. Just a minute. Suppose P is true. P is true. Q is true. P and Q is also true. But negation P. P true means this is false. Okay. False. P and Q are F means true. Next. P is true. Q is false. P and Q is false. Negation P is false. Negation P is false. Next one. So P and Q are negation P. This is the false. Next. P is false. Q is true. P and Q is false. P and Q is false. So negation P. Negation P is true because P is false. No? Negation P is true. So P and Q are negation P is negation P is true. Right. Suppose P is false. Q is false. P and Q is false. But negation P is true. This is also true. P and Q are negation P is true. Okay. Next, we'll discuss about tautologies. What are the tautologies from a discussion? A statement is obtained as a result of substituting definite statement for the variables continued in the formula. The truth values of resulting statement depends upon the truth values of the statement substituted for such variables. uh, Such variables. An entry in finding column truth tables depend only upon the truth values of the statement assigned to the so tautologies. 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 Huh? So tautologies means in the column truth value, truth tables. Suppose the example defined by truth table. PQ, PQ, PRQ, PRQ. P implies PRQ. P is true. Q is true. PRQ is true. P implies PRQ true. Next. P is true. And Q is false. PRQ is true. P implies Q is true. Next. P is false. Q is true. PRQ is true. P P implies Q is true. Next. P is false. P is false. Q is false. Q is false. PRQ is false. PRQ false. Then P implies PRQ is true. So in the last column, if you get all T means known as tautologies. All means tautologies. Suppose the last column, this is known as tautologies. Tautologies. Tautology. Suppose in the last column, you get all false like that. False, 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 false. This is known as contradiction. 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 No? Contradiction. A statement which is always true, no matter what is the truth values of the proposition occurs, it is called tautologies. Contradiction, a compound position. Contradiction. Contradiction. A compound proposition that is always false is called contradiction. Right. Next, contingency. 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 A proposition that is neither a tautology nor a contradiction is called contingency. Because neither tautology. For example, true, false, true, false. Either neither a tautology nor a contradiction is called contingency. Called contingency. Next, summary. So in this, summary in this unit, we have learned the logic. We always deal with declarative statement proposition which have only one or other of the truth tables, either true or false. The declarative statement which cannot be broken or split are called atomic, primitive, or simple statements. Statement obtained by joining two or more atomic statements are called molecular, means compound statements. So molecular statements involves the use of a few connectivities like negation, conjunction, disjunction, conditional, and biconditional, and they are well defined and discussed. A few rules for forming well-formed formulas are stated, and recursive definition of well-formed formula is given. The method of constructing the method of constructing a truth table for a given statement formula is described and illustrated. If the last column, the truth table, which described the truth values of the given statement formula shows all truth value true, then the formula is called tautology or universal truth. If it consists of all the truth values false, it is called a contradiction or absurdity. Okay, today we discussed unit 1. Unit 1. Unit 1, what is the statements, notations, connect phrases, truth tables, implications. Okay, tomorrow we'll discuss it. second unit. Okay, thank you very much. I'm leaving. Thank you very much, students. I'm leaving. Today we discussed one chapter unit. Tomorrow, another unit. Thank you very much.